Hello and welcome back everyone. So in this video lecture we are going to study about some more games with numbers and this will be our part 2 for the same. So first of all we again have this reversing of the digits, but now we will be dealing with the 3-digit numbers. Our first step will be to choose a 3-digit number. Our second step is to reverse those digits in order to get a new number. The third step will include subtracting the smaller number from the larger one. And at last, we will divide that result by 99 and we will see that the division will not have a remainder. That again our remainder will come to be 0. So let's just follow these steps for the given questions and we are asked to keep a record of the quotient obtained at the end also. So our first step is to choose this number, a 3-digit number. We are given that is 469. Our second step is to reverse the digits. So reversing the digits, I am getting 964. And my third step is now subtracting the smaller number from the bigger number. So I'll subtract this 469 from 964 and I'll get what? I'll get this as 5. 14 minus 9 gives me 5 and this is 8 and 15 minus 6 gives me, this is 9. And 8 minus 4 is 4. So this is coming to be 495. Now my next step is, the last step is dividing this number by 99. So let's divide 495 with 99. If I do 99 into 5, I'm getting 9 5s are 45. 5 9s are 45 and 495. So 99 into 5 gives me this number 495. So my quotient is 5. This is my quotient and my remainder is coming to be 0. Because this whole number 495 gets completely divided by 9, gives me the quotient 5 and remainder as 0. So you can see that yes, my remainder is coming to be 0 in this case when I followed all the 4 steps and my quotient is coming to be 5. So just remember this quotient, that is 5 and my digit was 469. Now please do these two parts, the part number 2 and part number 3 yourself, just following these 4 steps and just see what your quotient is and what your remainder will be. Let's see why does this happen, why is this always true. So let that 3-digit number in general be ABC. We know that ABC can be written in the generalized form as 100A plus 10B plus C. On reversing the digit, I am getting CBA and CBA can be written as, this CBA can be written as 100C plus 10B plus A, right? ABC, and on reversing the digits, I am getting CBA. CBA can be written as 100C plus 10B plus A. Now on subtraction, my first case is when A will be greater than C. So if A is greater than C, the difference of these two numbers will provide me 99 into, in the brackets, A minus C. Why? Because A is greater than C. My second case will be where C is greater than A. So in the case where C is greater than A, the difference of these two numbers will give me 99 and in the bracket C minus A, because in this case C is greater than A. So I'll get the difference as 99 into C minus A. And my third case is where both of these A and C are equal. So what happens when both of these A and C are equal? It's very obvious that my difference will be 0. So you can see that in each of these 3 cases, the resulting number is divisible by 99. Whether it's 99 into A minus C or 99 into C minus A or 0, all of these 3 are totally divisible by 99. And on dividing the result by 99, what will your quotient be? It will either be A minus C or C minus A. This depends on which digit is greater than the other. So it is exactly the difference between the units digit and the digit at the hundreds place of choose a number A and B. So let's just see, is this what we solved and found out the quotient? Is that quotient following this method or not? So my number was 469. Here C is greater than A, so my quotient should be C minus A, that is 9 minus 4, that is 5, and yes, my quotient was 5. So yes, in such cases when you follow all these 4 steps, your remainder will be 0, your quotient will be C minus A or A minus C, depending on which digit is larger. These were the 3 cases and we have concluded that yes, this is true. Now we are given forming 3-digit numbers with given 3-digit numbers. So we are given that our first step will be to choose a 3-digit number. Our second step will be to use this number to form 2 more 3-digit numbers. Let that if we choose a number, 3-digit number, ordinal number be ABC, then the first number can be CAB and the other number can be BCA. CAB and BCA, these two numbers can be formed using those 3 digits of that original number. Now, in the third step, we will be adding all these 3 numbers. The original number and the 2 new numbers we got from that original number, and at the last step, we will divide that sum of these 3 numbers with 37. We will divide that sum by 37. You will see that the division again will have no remainder. That is, our remainder will come to be 0. 0 again. Let's follow these methods, all these steps. Again, now we are given these 4 numbers and we have to see that what the result is. First step was to choose a number, 3-digit number. That is given to me 417. My second step was to form 2 more numbers using these 3 digits. So it will be 741 and I can write it as 741 and 174. Right, these 2 numbers 741 and 174 can be formed using the 3 digits of this original number. My third step is to add all these 3 numbers. On adding all these 3 numbers, I'm getting 417 added with 741 plus 174. When we will add these numbers, you will get 7 plus 1, 8 and 12. And here 8, 9, 13, 7, 8, 9 and again 13. I'm getting 1332 as my sum. My last step is to divide this number 1332 by 37. Let's divide this number with 37. I'm getting 37 into 3 gives me, let's do 4. 4 sevens are 28, 4 3s are 12, 13, 14, 148. It's coming to be bigger than 133. 37 into 3 gives me 3 sevens are 21, 3 3 9, 11, 100. 11 will be written here. It is 3. 3 minus 1 gives me 2, 3 minus 1, 2 and it's 222. So 37 into, let's say 6, 6 sevens are 42, 6 3s are 18 and 22. So yes, 222 and the remainder is 0. So yes, when I divided this sum 1332 by the number 37, I am getting my quotient as 36. My quotient is 36 while my remainder is 0. And this is what was written in the previous slide, that if you follow all these 4 steps, you will get your remainder as 0. In this case also, in this part 1, when I followed all the steps, my remainder is coming to be 0 and my quotient is 36. My quotient is 36. Now please follow all these 4 steps for these 3 parts, that is 632, 117 and 937. When you will follow all these 4 steps, you will again get your sum quotient and you will get your remainder as 0. Now why does this happen? Let's see. If the chosen number is ABC, it can be written as 100A plus 10B plus C. And the 2 new numbers can be, if it is the new number, one of the new numbers is CAB, it can be written as 100C plus 10A plus B. And BCA can be written as 100B plus 10C plus A. These 3 are the generalized form of these 3-digit numbers. Now what happens when we add the 3-digit numbers, three numbers? We're going to add ABC plus CAB and BCA. This will give us 111. When you will solve this, you will give us 111 into in the brackets A plus B plus C. Now this 111 can be further written as 37 into 3 into in the brackets A plus B plus C. And yes, you can say that the sum is always a multiple of 7. You can say that the sum is always a multiple of 7 because 37 can be taken out common from this whole sum. So this sum will always be a multiple of 37. This is we saw how. So this was all about these games with the numbers part 2. Let's now jump on to our second topic, that is letters for digits. So what is this letters for digits? Now in this section we will be solving some puzzles in which the numbers will not be written there, the digits will not be written there, but in the places of those digits we will have some letters. And we will follow some rules in order to find that letter actually represent which digit. We will find the digit that is being represented by that letter. So what are these rules? The first one is that each letter in the puzzle must stand for just one value, right? One digit. and each digit must be represented by just one letter. It means that if A is there in the question, in that puzzle, then A should stand for only one digit. Similarly, our second rule goes as the first digit of a number cannot be 0. So, for such letters for digits in those puzzles, the first digit of number can never be 0. So, these are the two rules that you have to keep in mind, and let's now jump on to the questions related to it. So, these were the rules. Now we have example number 1, and we need to find the value of Q, that here this letter Q stands for which digit in this addition question. So what are we given? Q, when we are adding Q and 3, we are getting 1. So we have to think, you have to brainstorm and you have to think the value of Q. What will be the value of Q such that when you will add 3 to that value of Q, you will get your ones digit as 1. So you know that after 3 we have, what number has the unit place digit as 1? That is 11. So what number should be added to 3 to get 11? The answer is 8. So what if I take Q as 8? This answer will be 8, 9, 10, 11, 1. 1 will be here, 1 and 2. Now this Q is already taken as 8 because of the first rule. Q will again be 8. Q now in the second part cannot be some other digit, but it has to be 8. If first time Q is 8, then this time also Q has to be 8. Now 8, 9 and 10, yes, 0, and here 1, 3, 4, 5. So yes, this is correct if I am taking Q as 8. So this answer is 318 plus 183, that is equal to 501. You can check this out, solve these, and you will get their sum as 501. This is how you proceed such questions. Now we have to find now the values of A as well as B. We're given A plus A plus A equals to BA. Now just think of a digit that when added to itself or 3 times, right? When a digit, when added to itself 3 times, that is A plus A gives the same digit at its unit place. So such a digit can be either 0 or 5. You can see like 0 plus 0 plus 0 gives us 0 again. And 5 plus 5 plus, just a second, one more 5. 5 plus 5 plus 5 gives us 15. That is 5 again at the units place. So either this number will be A, either this letter A will be 0 or it will be 5. What happens if this A is 0? We will get 0, 0, 0, 0. B will also be 0, which is not possible because we will get 0, 0, and because of rule 2, 0 should not be at the first place of that digit. So the other and the only value for A is 5. So A will be 5. In that case, if A is 5, our B is 1. So this is this. 5 plus 5 plus 5, and we get 15 as the answer. So this is how we did this. Now we have a multiplication question. The previous two were related to addition, and now we have this multiplication question. We need to find the digits A and B, both of these. Now again we have this A. When this, you know how we proceed multiplying it, we will first multiply 3 with A and then 3 with B. So what is that digit when multiplied by 3 gives us that same digit at its which value? Unit value. So that if you brainstorm, you will get that A can either be 0 because 0 into 3 gives us again 0, or A can either be 5 because 5 into 3 gives us 15, that is again 5 at the units place. And for B, when you think of B, let's just first of all take B as 1. Now what happens when B is 1? Then this implies that BA into B3 will have a maximum value of 19 into 19. Right? This thing will have a maximum value of this 361. But at the end, our product is 57A, that is greater than 500. Therefore, we cannot take B as 1. No, we cannot take B as 1 because if we take B as 1, our product will be equal to or lesser than 361, which is not the case here because our product is greater than even 500, that is 57 something. So we cannot take b as 1. Now what if we take b as 3? So if b is taken as 3, then our BA into B3, BA into B3, yes, BA into B3 will have the minimum value. It will have the minimum value. It will be greater than equal to this third. Wait, I'll write it again. It will be greater than equal to, if b is 3, it will be greater than equal to 30 into 30, that is 900. So if b is 3, this product will be greater than 900. But we just need it around 507 something. So we cannot take b as 3. B cannot be 1, B cannot be 3, but has to be in between these two. That is B is 2. So B is 2. This is final. Now we are going to decide the value of A. Now what if I write A as 0? Because A can either be 0 or A can either be 5. This 5. So what if I write A as 0? I get 20 into 23. That is, I'm getting the answer as 460, but this is not right. But when you will do 25 into 23, that is, you take A as 5, you will get your answer as, solve it, 3 5s are 15, 3 is 6, 7, 2 5s are 10, 2 2s are 4 and 5, that is 575. And yes, A was taken to be 5, A was taken to be 5, B is 2. So this is your answer. Your B is 2 while A is 5. So this is how you proceed doing questions for letter for digits. You first of all brainstorm, you take some conditions, and then at last you check it out that whether when you put those values that you have decided at the place of those letters, is your answer coming to be same as in the question or not. Now you have to do this. Write a two-digit number AB. So first of all, if you write a two-digit number AB and then the number obtained by reversing its digits, that will be BA. First of all, write a two-digit number AB, then find a new number that will be obtained by reversing its digits, that will be BA. Now find their sum, that is AB plus BA. Let that sum be a three-digit number. Let that sum be a three-digit number, that is DAD. That is AB plus BA gives us DAD, a three-digit number. We have already done this, that when we add this AB plus BA, we are going to get 11 into A plus B. Therefore, we can write this thing as AB plus BA can be written as 11 into A plus B, which further is given to be equal to DAD. Now, think of this. Can the sum A plus B exceed 18? No. Why? Because the maximum value of A will be 9. Maximum value of B can be 9. Therefore, their sum's maximum value will be 18. No. Their sum will be either equal to or less than 18. So, their sum cannot be exceeding 18. But now, is DAD a multiple of 11? So, yes, DAD is a multiple of 11. You can see 11 into A plus B is equal to DAD. Therefore, it is a multiple of 11. 11 is taken as common. And is DAD less than 198? So, A plus B is less than 18, you know. So, if A plus B is less than 18, we can, from this it implies that 11 into A plus B will be less than equal to 11 into 18. That is less than equal to 198. So, yes, this is less than equal to 198. And further, you are asked to write all the three-digit numbers which are multiples of 11 up to 198. And then you need to find the values of A and D. So, I'll write sum and you write the left three-digit numbers that are multiples of 11 up to 198. So, 11, 22, 33, 44, 55, 66, 77 and so on till 198. You have to fill this. And then you have to check the values of A and D in those cases. This part I am leaving it to you because I have done all the parts. You can take hints from here and you have to fully write all the other multiples of 11 up to 198. That is all the three-digit numbers. That will be after 88, 99 and then after 99. You will get your other multiples of 11, the three-digit numbers which are multiples of 11 up to 198. So this was all about this video lecture. In the next video lecture, we are going to learn about the tests of divisibility. First of all, we'll do the part 1 for it and then the part 2. I'll meet you all in the next video. Till then, bye-bye.